Okay, students, can you all hear me? Can you hear me? Okay. Right. So, good morning for all of you. So today we are going to discuss some uh, reactions related to the redox. That means we have to balance redox reactions using the oxidation number method. Ne? So in the last Thursday theory class, we discussed 11 reactions. In this whiteboard, I discussed 11 reactions. So we have to discuss all together 20 reactions. And did you try the questions that I uploaded? 11 to question number 12 to 20. Did you try it? So you have to try that one, okay? What about the others? Did you try the questions? Right. Then let's see what are the doubts you have. And if you have done any mistakes, you can correct them by looking at balancing reaction. Okay? In addition to that one, in the tutorial page number, in the exercise, I have given you another 20 reactions. And let's balance those 20 reactions also today. Then we can finish balancing redox reactions, right? So these are enough. You know that how to balance a redox reaction. Let's go for the 12th one. Number 12, they have given sulfuric potassium permanganate with hydrogen peroxide H2O. Remember, students, first of all, you have to know how to predict the products. So we learned that one. Definitely in the acidic medium, you know that the reduction, right? Under the reduction half reactions I gave you, then is in an acidic medium. Permanganate is going to convert into Mn2. No doubt about it. And if manganese is reducing, then hydrogen peroxide should oxidize. So this is what you have to understand here, right? Because I gave you hydrogen peroxide in both oxidation half reactions and the reduction half reactions. You have to understand whether hydrogen peroxide is oxidizing or reducing. Remember, permanganate is going to reduce. If permanganate is reducing, definitely hydrogen peroxide should oxidize. Then hydrogen peroxide is going to oxidize into what? It's going to oxidize into oxygen. Right? So these are the reduction half reactions and the oxidation half reactions that you have to remember. Right? So by depending on these things, now you can predict the products. You can obtain the products. Mn2 plus. Mn2 plus cannot be written alone. Mn2 plus should be neutralized by the anion sulfate, then MnSO4 is produced. So that is the major product. And the second one, oxygen, O2, right? And we know that permanganate left potassium. Now potassium is alone in the left-hand side. So we have to mention potassium in the right-hand side as well. And potassium should be written in this way now. K2SO4 plus definite byproduct is water, H2O. See here, we have obtained the products in this way. Now do the balancing part, right? We have to get the total increment and the decrement. If not, the total number of electrons removed with the total number of electrons gained. So let me see in this way. Manganese oxidation state is +7. Manganese oxidation state is +2 here. +7 to +2, we can see that the decrement is 5 electrons. Okay? Students, be careful. In hydrogen peroxide, there are 2 oxygen atoms, and here also we have 2 oxygen atoms. So therefore, you have to count 2 oxygen atoms, oxidation state for 2 oxygen atoms, not for one particular oxygen atom. In hydrogen peroxide, as we know, 2x, that means the hydrogen is 1 plus 2x, summation is equal to 0, then 2x equal -2. That means oxygen's oxidation number, right? For one oxygen, it is -1, x equal -1. For 2 oxygen atoms, it should be -2. So since there are 2 oxygen atoms in both sides, we have to consider -2 because we are taking the total increment and the decrement. Right? Then -2 here. And here oxygen, this is a free element. If it is a free element, we know that oxidation number is 0. Then -2 to 0, you can see that the increment is 2 electrons. That means hydrogen peroxide has removed 2 electrons when it is converting into oxygen. Now we have to equalize the total increment and decrement. So you can see that the decrement is 5, increment is 2. You can multiply this one by 2. That means you are going to multiply this reduction reaction by 2 and this one by 5. That means you are going to multiply oxidation by 5. Put the coefficients 5. Can you understand? Very easy. Then hereafter you can see that in the left hand side there are 2 potassium atoms. So that is constant. That is not changing in the left hand side. And then in the right hand side also number of potassium atoms should be 2. Then you can put here coefficient number 1. Now you can count here the number of sulfatoms in the right hand side. Here we have 1 and here we have another 2 sulfatoms. Altogether there are 3 sulfatoms. Then we can put here 3 sulfuric. 3 sulfuric. Understood? Right? Then count the number of hydrogens. See how many hydrogens are there? 3 into 2 is 6 and here 5 into 2 is 10. Then there are 16 hydrogen atoms. So here 16 hydrogen atoms. In order to assign 16 hydrogen atoms, you have to put 8. Finally, how do you check whether this reaction is perfectly balanced or not? By counting oxygens. Right? So you can count the oxygen atoms in the left hand side. First of all, 3 into 4 is 12, 2 into 4 is 8, 5 into 2 is 10, and then the summation is 30. Go for the right hand side. 2 into 4 is 8, 5 into 2 is 10, 4 here, 8, and then you can see that 8, 8, 16, 4, 20, 30. All the oxygen atoms are balanced. So it's confirmed that the reaction is balancing perfectly. So this is the 12th one I gave you. Please raise your hand who balanced the reaction perfectly. Please raise your hand who balanced this one perfectly. Vidushana, Pabasara, Zainab, Yasasi, Dishon, Nilojan, Akshada, Vibashi, Sharfa, Yanuli, Lakshika. Okay, good. Marisha, okay, good. You should be able to get the answers, huh? You should be able to balance these reactions. Okay, are we done? Shall we go for the 13th one? Quickly complete this one. Right. Now let's go for the question number 13. Question number 13. They have given that chlorine is reacting with hot concentrated sodium hydroxide. And let's see how to balance this. Number 13. Students, if you have any doubts, put your doubts in the chat box. Right? Hereafter, redox should be nothing for you all. Hari mewa gameak නැති වෙන්න ඕනේ. ඉස්සරහට මේව නිකන් ගොම් පාට් වගේ දේවල් එන්න ඕනේ. හරි. So number 13. Chlorine is reacting with hot concentrated sodium hydroxide. When chlorine is reacting with hot concentrated sodium hydroxide, so we have discussed this one in the last Thursday theory class also. I told you that conditions are very important. If they have given the conditions like hot concentrated sodium hydroxide, then you should be able to predict you have to obtain the relevant products. If it is cold diluted sodium hydroxide, then you should know what are the products, right? Okay, then we know that this is a disproportionation reaction. So the reduction is clearly chlorine is going to convert into Cl minus. So this is the reduction. And what is the oxidation? I gave you that under the hot concentrated OH minus, what will happen to chlorine? Chlorine is going to convert into ClO3 minus, chlorate. If it is cold diluted OH minus, cold diluted basic medium, chlorine is going to convert into hypochlorite, ClO minus. So this is ClO3 minus. Got it? Therefore, you can write down here Cl minus, ClO3 minus are the major products, but we know that we cannot write down these things as anions. We have to neutralize them. So we can neutralize these things by giving the cation from the base, right? Sodium hydroxide here is the base. Then connect these anions with sodium. Sodium chloride, sodium chlorate NaClO3, and the definite byproduct is water. Now do the balancing part. Students, you can see that this is a disproportionation reaction. Chlorine 0. And here chlorine R. Be careful. Here we have chlorine. There are 2 chlorine atoms in this molecule. Here we have only 1. Therefore, let me put here 2. Right? So first of all, when you are taking the oxidation number for the element who is changing the oxidation state, we have to check whether the number of atoms are equal in both sides. Then only we have to go for the balancing part. So here chlorine minus 1. Since there are 2 atoms now, it should be minus 2. Then 0 to minus 2, you can see that the reduction is 2 electrons. Chlorine is gained 2 electrons to produce this Cl minus. Then the next thing is, now you can consider the same molecule, doesn't matter, right? So later you will understand without writing. Now I'm going to write down another chlorine molecule. Why? I'm going to write down another chlorine molecule here, students, because I want to show you these chlorine molecules are clearly reducing and oxidizing. I want to show you the reduction and the oxidation properly. So therefore, I'm going to put chlorine molecule, another chlorine molecule in the left-hand side, right? So is it okay? Yeah, it's okay, fine, because we know that more than 1 chlorine molecule should be there. Okay, always more than 1 chlorine molecule should be there. So therefore, let me put here another chlorine, because then only I can show the oxidation clearly, right? So I'm going to show you the oxidation clearly in this way. Now there are 2 chlorine atoms, so therefore you have to equalize the atom. What is the oxidation number of chlorine molecule here? 0. And here we can see that chlorine's oxidation number ClO3 minus means chlorine's oxidation number X minus 2 into 3, summation is minus 1. Then X equal plus 5. For the 2 chlorine atoms, that will be plus 10. Then 0 to plus 10, you can see that increment is 10 electrons. Can you see that? I want to show you the clear oxidation and the clear reduction in 2 chlorine molecules separate, right? So later I'll teach you how to keep the same chlorine molecule and balance this. Okay? Then we have to equalize the total increment and decrement. Therefore, I'm going to multiply this one by 5 and this one by 1. Then okay, 10 and 10. Increment, decrement, both are equal, right? Then put here 1. Then this is not changing. Here we can put 5. Remember, here we have 2 as the coefficient already. When you are multiplying this one by 5, 2 into 5 is 10. So you have to change it as 10. Now okay, right? So how many sodiums are there? 12 sodiums are there. Therefore, we can put here 12. How many hydrogens are there? 12. Therefore, let me put here 6. And you can check whether reaction is balancing or not by counting oxygen. There are 12 oxygens. And here also you can see that 2 into 3 is 6. And here also 6. 6 plus 6 is 12. Reaction is balancing. But here you have to remember something like this, students. Look at this one. These coefficients are simplifying, and we don't have to keep this chlorine in this way. One chlorine molecule, 5 more chlorine molecule. All together, there are 6 chlorine molecules. Right? And here we have 12 sodium hydroxide, 10 sodium chloride, 2 sodium chloride, and then 6 H2O. Right? So can you see that all the coefficients are even numbers? 6, 12, 10, 2, 6. You can divide them by 2. 6 here, 5, 1, 3. That means you can write down the reaction: 3 chlorine, 6 sodium hydroxide, 5 sodium chloride, sodium chlorate, and 3 H2. In this. So this is the balanced reaction. This is the final reaction that you have to obtain. Okay. So you can't stop by here. You can't stop by here. Because in the balanced reaction, always they are expecting the most simplified stoichiometry ratios. These are known as stoichiometric coefficients. These are the most simplified stoichiometry ratios. Right? Then okay, there are 6 chlorine atoms, 6 sodium atoms, 6 oxygen, 6 hydrogen. So everything is perfect. Okay. Quickly complete this one. If you have any doubts, put your doubts in the chat box. Huh? Right, okay. Now look at this one, students. So what about if I balance the reaction without adding chlorine here? Now separately I put here chlorine molecule. Without putting a separate chlorine molecule, can we balance this reaction? Yes. Look at this method also. Because some of the students are following many short methods to balance reactions in order to go for the answers within a short time period. So therefore, that's very important. Look at this one. So the reaction is chlorine reacting with sodium hydroxide, hot concentrated sodium hydroxide to produce sodium chloride, sodium chlorate plus water, H2O. Now I'm not going to add another chlorine molecule. So let me keep the chlorine molecule as it is, right? Then we can write down there are two chlorine atoms. Then we can put here 2 here and 0 minus 2. Right? If not, what about if I consider in this way? Look at this one very carefully. Yeah? Chlorine. There are two chlorine atoms. Let me consider one chlorine atom is going from 0 to -1 here. In that chlorine molecule, there are two chlorine atoms. So just imagine one chlorine atom is came to here and the other one is converted as ClO3 minus. Then 0 to -1, you can see that what is the decrement? You can see just one electron, just one electron. And here you can see that another chlorine atom is there. So that is converted into NaClO3. So here also chlorine's oxidation number 0, 0 to +5. 0 to +5, what is the increment? We can say that increment is 5. Then what we have to do? We have to equalize the increment and the decrement. Then I'm going to multiply this one by 5. That means you are going to multiply the reduction reaction by 5. And here we have to put 5. And here we have to put 5. 1 here. And here also we have to put 1. But remember, students, you can see that we got the oxidation and the reduction correctly, right? One chlorine atom is converting into Cl. So therefore 0 to -1. So here chlorine is oxidizing from 0 to +5. That's also correct. Fine. But remember, you can see that in the right-hand side, there are 6 chlorine atoms, right? There are only 6 chlorine atoms. Here we have 5 chlorine atoms. That means there are 10 chlorine atoms, 5 chlorine molecules. That means chlorine atoms are not balanced, right? So why did this happen? Remember, this is chlorine molecule. This is chlorine molecule. When we multiply this one by 5, so the complete molecule multiplied by 5. But we know that this chlorine molecule is made by 2 chlorine atoms. You have to just multiply one chlorine by 5. And the other one is not multiplied by 1. Anything. So that is remaining as it is because it is multiplied by 1. That means you can see that 5 chlorine atoms and here we have another chlorine atom. Altogether there are 6 chlorine atoms. Then how much chlorine molecules I should add here? 3 chlorine molecules. Right? So you have to take that one. So this is analytical thinking. Right? Otherwise, if you can't balance in this method, you go for the previous method. Doesn't matter. You can write down a separate chlorine molecule and show the oxidation reduction separately. But you can see that here we don't have to follow any longer method. That means we don't have to go for this simplified methods or anything. Directly you can get the answer. But here we have to be very careful. Right? Look at this one. Chlorine molecule is made by 2 chlorine atoms. I took that one is converting into Cl minus. That means 0 to minus. And the other one is converting into +5. 0 to +5. Then you have to understand that there are 2 chlorine atoms. So you can't directly multiply this molecule by 5. Then the chlorine atoms are imbalancing. Then what I'm going to do here, I wrote this chlorine molecule separately in this way, maybe one chlorine atom and the other one. So that chlorine atom which is converting into chloride only should be multiplied by 5. And the other one remaining as it is. Then altogether there are 6 chlorine atoms. Then we can see here 3 chlorine molecules are. Right? So this is the way that we are balancing this one, even a shorter method. Right? Tell me if you have any doubts. So should we do every disproportionation reaction in this way? Yes, we can balance the disproportionation reactions in this way. Yeah, everyone, because we know that same molecule is oxidizing, reducing. So yeah, this is the shortest method. Okay. If you can't do in this method, doesn't matter, students. The method that I gave you previously, you can follow that. Right? Don't think too much. First of all, practice these reactions. Okay. Sometimes it will take some time. It's okay, because this is beginning, right? Later, when you are doing a lot of calculations and everything, by the time, so you will be able to balance these reactions. Okay. Some of the students are memorizing these reactions, but you don't do that one, right? Please don't do that one. So you should be able to balance this one by thinking, right? Because you know what is oxidation, what is reduction. I taught you everything perfectly. So you have to balance this one and this. Okay. Yeah, this is the number 13 one. Dwara actually yesterday only 25 paper class conducted, Dwara. Friday night. Friday night only 25 paper class is conducted. I think I sent you the wrong link, I guess. This is actually an extra class for 26 batch. You attended, right? Yesterday you attended. Oh. Then this is for 26 batch. Now doesn't matter. Okay. If you want to learn redox, stay and learn redox. Right, students, do you have any doubts regarding this reaction? Anything? I gave you a longer method and a shorter method, even shorter method. So you should be able to balance these reactions. Shall I go for the next one? So the next one is potassium hydroxide is reacting with CrCl3 in the presence of hydrogen peroxide. Let's see. Number 14. Please practice these reactions. These things are very, very important. Okay. Potassium hydroxide is reacting with CrCl3 and H2O2. So first of all, let's obtain the products. Can you remember? I taught you that in the basic medium, oxidation, neither under the oxidation half reactions, I gave you that in basic medium, Cr3 plus is going to convert into CrO4 2 minus. Then CrO4 2 minus is the major product, but we have to neutralize that one by connecting to potassium, then K2CrO4. And we know that reduction. Students, what is the reduction? So we can consider that the reduction is hydrogen peroxide is going to convert into H2O. In the previous reaction, I think in the question number 12, we discussed that hydrogen peroxide is oxidizing into oxygen. But here hydrogen peroxide is reducing into water. So this is a reduction reaction. Understood? So therefore, one of the major products will be water, H2O. Then we know that potassium, chlorine is there, chloride anion is there. Chloride anion should be neutralized by KCl. Potassium plus, then KCl is produced. And again, I'm going to add water molecules. Why? What is the reason? Students, remember, now in this reaction, you can see that there are two types of water molecules. Right? Later, you can add them. Now we can put here two types of water molecules. Why? The reason is hydrogen peroxide is reducing into water. So these are the water molecules came from the reduction of hydrogen peroxide. And these are the water molecules of the byproduct of the reaction. These are the water molecules of byproduct of the reaction. So therefore, there are two types of water molecules. Try to understand that. Now go for the balancing part. You can see that chromium's oxidation number here it is +3. Here chromium's oxidation number +6. +3 to +6, you can see that the increment is 3 electrons. Okay. And in hydrogen peroxide, as you can see here, there are 2 oxygen atoms. And here we have only 1 oxygen atom. Then we have to equalize the atoms who are changing their oxidation states. So here we can see that oxidation number summation is -2. And here -4. -2 to -4, decrement is 2. -2 to -4, decrement is 2. Then you can multiply this one by 3. That means you are going to multiply the reduction reaction by 3. So already we have 2 here. So therefore, when you multiply that one by 3, it becomes 6. And you are going to multiply this one by 2. That means you are going to multiply oxidation reaction by 2. Right? Now, did you notice that in the left-hand side, the chlorine atoms are completed. 2 into 3, 6. Then you have to equalize that one by adding 6 KCl. Then we can see that in the right-hand side, the number of potassium atoms are 6 here and here 4. Altogether, there are 10 potassium atoms. Then let me put here 10 potassium hydroxide. 10 potassium hydroxide. How many hydrogen atoms are there in the left-hand side? 10. 3 into 2 is 6. So therefore, 16 hydrogen atoms are there. 16 hydrogen atoms means we can put here 8 water molecules. 8 water molecules. Finally, sorry, in order to check whether the reaction is balanced or not, you can count the oxygen atoms 10 here, 6, 16, and here we can see that 2 into 4 is 8, 6, 8. So you can see that answer is 8 here, 6 here, and 8. 26. Reaction is not balanced. Why is it? Right. This is the mistake. Look at this, Anilu. We took that total number of hydrogen atoms are 16, no? We can see that there are 12 hydrogen atoms already I have put here. Already 12 hydrogen atoms are there. So therefore, we need 16. That means 4 more. Therefore, you have to put here only 2 water molecules. Right? Only 2 water molecules. Now count the oxygen atoms. Now count the oxygen atoms. 10 here, 6 here, 16. And here we can see that 2 into 4 is 8. And here 6, 2 here, and then 16. Reaction is balanced, right? If you want, finally you can add them. Water molecules make 6H2O, 2H2O. You can write down directly that is as 8H2O, right? Don't write down in this way. Finally, you have to write down the reaction as, let me write down here. 10 potassium hydroxide reacting with 2 CrCl3, 3 hydrogen peroxide to give 2 potassium chromate, 8H2O plus 6 KCl. This is the final balanced chemical reaction. Okay, keep that in your mind. Please raise your hand who got the answer correctly. Okay, yes, some of the students are there. This is okay, right? Eight water molecules becomes, because there are 6 water molecules, 2 water molecules, add them together, then put here 8H2. Okay, Vidushana? So this is question number 14. Shall we move to the 15th one? Yeah. Let's go for the 15th one. Number 15. Check whether you have balanced the reactions correctly. So the 15th one says that zinc is reacting with arsenic acid H3ASO4 and HNO3, nitric acid. So they're asking to obtain the products and balance the reaction. Students, remember, the first thing you have to understand here, oxidation. Who is going to oxidize? So we have zinc metal. So therefore, zinc is going to convert into zinc 2+. So that is the oxidation. And the reduction is, if you clearly see the list that I gave you, reduction half reaction list, in that list I gave you that H plus is reacting with this arsenate anion in the presence of acidic medium. Arsenate anion is going to convert into cation AS3 plus, arsenious cation, right? AS3 plus. Then we have to write down the products for this one. Zinc 2 plus, you can see that zinc 2 plus should be neutralized by the anion from the acid. Remember here, acid is actually nitrate. Then we can write down zinc 2 plus will be neutralized by the anion, zinc nitrate is produced. Then arsenious AS3 plus, this is the cation arsenious. So arsenious cation AS3 plus should be neutralized by the anion NO3 minus, then AsNO3 thrice. These are the two major products. And the next thing is, you can see that what are the byproducts? Anything else? Yeah. We can write down the main byproduct is what? That's all. That's all about this reaction. These are the products that we can obtain. Now we have to do the balancing part. Look at this one. Zinc is oxidizing from 0 to +2. 0 to +2, we can see that the total increment is 2. Okay. And then you can see that here, arsenic oxidation number is +5. Here, arsenic oxidation number is +3. So +5 to +3, you can see that the decrement is 2. Increment, decrement, both are same. Students, you can see that increment, decrement, both are same. That means 2 and 2. That means you are just keeping the coefficients as they are. 1, 1, 1, 1. Right? Now count the total number of nitrogen atoms in the right hand side. Here we have 2 and here we have 3 nitrogens. 2 here and 3 here. All together there are 5 nitrogens. Then how many nitric molecules I should add here? 5. 5 nitric molecules. Then count the total hydrogen atoms. 3 here, 5 here, 8. Then we can put here 4 water molecules. Finally, to confirm whether the reaction is balanced or not, you can count the oxygen atoms. 4 here, 5 into 3 is 15, then 19 oxygen atoms are there. And here you can see that oxygen atoms, 3 into 2 is 6, 3 into 3 is 9, and here 4, we can see that 10, 19. So it's confirmed that the reaction is balanced. Easy. Right? So please raise your hand who balanced this reaction perfectly. Please raise your hand who balanced this reaction perfectly. Yes, very good. Yeah, some of the students are there. Nice. If you have any doubts, tell me. Put your doubts in the chat box. Right. Let's go for the 16th one. Okay. Are we done? Are we done with this one? Number 15. Do you have any doubts there? No, right? Let's quickly move to the 16th one. In the 16th one, I have given you students in sulfuric medium, ferrous oxalate is reacting with potassium permanganate, KMnO4. Right. First of all, we have to obtain the products. Let's see. We know that simply we know that permanganate is going to convert into Mn2 plus. Mn2 plus will be neutralized by the sulfate. Then MnSO4 is the one of the major products. Ferrous oxalate is special. The reason is in ferrous oxalate, both the cation and anion oxidize. Right? Remember in the examination, if they have given ferrous oxalate, FeC2O4, remember FeC2O4 is made by Fe2 plus cation, ferrous cation and oxalate anion. You go and check the oxidation half reaction list that I gave you. I given you there. F2 plus is going to oxidize into Fe3 plus, as well as oxalate is going to oxidize into carbon dioxide. Both are there. Then students, we have to consider both of them. Because balancing a redox reaction means we have to consider the total increment and decrement both. Can you understand? Then we can see that Fe3 plus is produced, that Fe3 plus should be neutralized by sulfate, then ferric sulfate, Fe twice, SO4 thrice is produced. And the next thing is oxalate is going to convert into carbon dioxide. Carbon dioxide is already in the neutral form. And one of the byproducts K2SO4 and H2O. Now do the balancing part. That's all. Now obtaining products and everything are nothing for you, right? Let me consider here. Manganese oxidation state is +7. And now manganese oxidation state here +2. +7 to +2, we can see that the decrement is 5. Then go for the ferrous oxalate. Remember, students, we know that iron atom, Fe, carbon atom, both are changing their oxidation states. These are the half reactions. Then you have to be very careful. Can you see that in the right hand side, there are 2 iron atoms? Then we have to put 2 iron atoms here first of all. That means we have to put 2 here and then take the oxidation numbers of both the iron atoms. Ferrous oxalate is made by Fe2 plus cation and oxalate. Then iron's oxidation number is +2. Since there are 2 atoms, we have to take that one as +4. This is ferric oxalate. Ferric oxalate means Fe3 plus and sulfate. In ferric sulfate, we can see that iron's oxidation number is +3, but there are 2 iron atoms, then +6. +4 to +6, right? +4 to +6. And the next thing is here +4 and here +6. The next thing is carbon. Now, can you see that how many carbon atoms are there? After adding 2 here, how many carbon atoms are there? 2 into 2, 4. So therefore, let me put here 4 carbon dioxide first of all, because I want to equalize the carbon atoms. It's changing the oxidation state. Then we have to consider the total increment. In oxalate, what is the oxidation state of carbon? C2O4 2 minus. Carbon is 2x, oxygen minus 2 into 4, summation is minus 2. So therefore 2x equal plus 6, x equal plus 3. One carbon atom's oxidation number is plus 3, but there are 4 carbon atoms. Then we have to consider plus 3 into 4 is plus 12. Plus 12. So here we know that in carbon dioxide, what is the oxidation number? Carbon's oxidation number is plus 4. There are 4 carbon atoms, so therefore plus 16. Students, you can see that the total increment. Look at the total increment. Huh? The total increment is plus 16 to, this is plus 16. And here we have plus 6 plus 16. Then what is the summation? Plus 22. Plus 16 to plus 22. The total increment is how much? 6 electrons. Then we have to put 6. Can you understand? This is the way that we are balancing. Now, we have to equalize the increment and decrement. Therefore, let me multiply this one by 5, this one by 6. Put here 6. And then you can see that you are going to multiply this one by 5. Already 2 is there as a coefficient. Listen to this one now. This is very important reaction. You are going to multiply this one by 5. So that means already 2 is there. 2 into 5, what is it? 10. 2 into 5, it is 10. And here you are going to multiply this one by 5. But remember, there are 2 compounds. Right? There are 2 compounds. So therefore, you have to multiply both of them by 5. Don't forget one. Right? You have to multiply both of them. You are going to multiply total increment by 5. That means you are going to put 5 here. And here also we have to put 5. But remember, there is a coefficient 4. Then you have to multiply 4 by 5. Then the answer is 20. 20 carbon dioxide molecules are there. 20 carbon dioxides are there. Right? 20. Try to understand. Okay, then increment, decrement, everything is okay. Now, students, as you can see here, how many potassium atoms are there? How many potassium atoms in the left hand side? 6. Then we can put here 3 potassium sulfate. Now count the sulfate atoms in the right hand side. Here we have 3 sulfate atoms. 3 into 5, 15. And there are another 6 sulfate atoms. So therefore you can see that 18, 24 sulfate atoms are there in the right hand side. You have to equalize that 24 sulfate atoms. Then what is the coefficient I should add here before solving it? What is the coefficient? 24. 24. Because I need 24 sulfate atoms. I think the coefficients are very big. So what about the hydrogen atoms? 24 into 2, 48. Then we have to equalize the hydrogen atoms. Hydrogen is only containing in water molecules. So therefore we have to put 24 water molecules. Finally, how do you check whether the reaction is balanced or not? By counting oxygens. Let me count the oxygens. 24 into 4, 16, 1, 96. Then here we have 10 into 4, 40. 6 into 4, 24. So here this becomes 100, 120, 160. 160 oxygen atoms are there in the left hand side. Now let's go for the right hand side. In the right hand side, 6 into 4, 24. 3 into 4 is 12. 12 into 5 is 60. 20 into 2, 40. 3 into 4, 12. Plus 24. 24, 24, 48. 48 plus 12 is 60. 60, 60, 120. 120 plus 40 is 160. Right? Doesn't matter if they are giving 1000 oxygens, also doesn't matter. If we are following the correct method, the reaction should be balanced. Right? And the next thing is, sometimes you might think that, sir, can't we simplify these coefficients? Because we have 10, 24, 6 like large numbers, 20 here. So can't we simplify? No. The reason is actually here we have 5 and 3. These are odd numbers. So therefore we can't simplify them. Right? So this is the balanced reaction, balanced chemical reaction. In many times in the examination, they have asked about this permanganate ferrous oxalate reaction. Okay, so therefore ionic reaction also we are going to learn under the half reactions. So, but here this is the short method that you have to know. Please raise your hand who got the answer for this one. Correct answer before I do. Vidushana, very good. What about the others? Anyone else? Dishon, mute your microphone. Anyone else got the answer for this one? Amarisha, good. Very good. Okay, right. It's okay, Dishon. Fine. Right. Shall we move to the 17th one? Okay, students, in the 17th one, so this is not a typical reaction. That means we can't obtain the products for some redox reactions according to the rules that we have learned. In that case, they will give you the products. So then what we have to do is we have to identify the oxidation and reduction and we have to balance them. That's all, right? If something is not related to our syllabus, so therefore they will give you the products. You have to find out the oxidation and reduction and balance that one. So likewise, I have given you the 17th one with the products. Potassium hydroxide is reacting with chlorine, Cl2, and CrI3, chromic iodide. So they are producing potassium chromate K2CrO4, then potassium periodate KiO4, KCl, and water. Right. So let's do the balancing part. So here we can see that chlorine is reducing. There are two chlorine atoms. So therefore, let me put here 2. Here 0. 0 to -2, you can see that reduction is 2 electrons. So what is the oxidation? You can see that chromium here, it is +3. And here chromium is +6. Students, did you notice that iodine also oxidizing? Right? This is also same kind of a thing as ferrous oxalate. Cation, anion, both oxidizing. Chromium's oxidation number, it is +3. And chromium's oxidation number here, it is +6. Remember, there are 3 iodine atoms, right? So therefore, put here 3 first of all. Then take the oxidation number. 3 iodine atoms, -1 into 3. So therefore, -3. What is the oxidation state of iodine in potassium periodate? Potassium +1, iodine X, oxygen -2 into 4, summation equals 0. Then we can tell that X -7 is equal to 0, X equal +7. Oxidation number of one particular iodine atom is +7. But here we have how many iodines? 3. Therefore, +7 into 3 is +21. Right? So now take the total increment and decrement. +3 -3, 0. 2, 6 plus 21, 27. That means the total increment is 0 to 27. How many electrons? 27 electrons. 27 electrons. Got it? Now, what we have to do? We have to equalize the increment and the decrement. You are going to multiply this one by 27. That means we can put here 27. Already we have the coefficient 2. But we can multiply that one by 2 and put 54. 27 into 4 is 27 into 2 is 54. And you can multiply this one by 2. Put 2 here. Then we know that we have to multiply both of them, right? Both of them. We can put 2 here. And we can put 3 into 2 is 6 in this way. Right? So balance it correctly. Huh? How many potassiums are there? In the right hand side, 54 plus 6 plus 4. So there are 64 potassium atoms. 64 potassium atoms. How many hydrogens are there? 64. 64 hydrogens are there. Then let me put here 32 water molecules. Now count the oxygen atoms. In the left hand side, there are 64. In the right hand side, how many oxygens are there? 2 into 4 is 8. 6 into 4 is 24. And here 32. 32, answer is 64. So the reaction is balanced. The reaction is balanced. This is what I gave you as the reaction number 17th one. Reaction number 17. Right? Please raise your hand who balanced this one perfectly. Please raise your hand who balanced this reaction perfectly. Vidushana, good, very good. Marisha, very good. Others, if you have any doubts, tell me. What are the doubts you have? Right. Now let's move to the question number 18. Students, question number 18 is a statement actually. They have given that first of all, raise your hand who balanced the question number 18, 19, 20. Those three reactions. Anyone here? Anyone here who got the answers correctly for 18, 19, 20? Okay, no one is there. Right. Okay, doesn't matter. So read the question carefully. Huh? Copper metal has sometimes been found to be react with nitric acid to produce both nitric oxide and nitrogen dioxide. Write balanced chemical equation for this reaction. Right. So they have given that copper metal sometimes to be found that it is producing nitrogen oxide and nitric oxide and nitrogen dioxide, right? Then let me put here nitric oxide and nitrogen dioxide. We know that definitely water should be a byproduct. And students, what will happen to the copper metal? How we learn? What will happen to the copper metal? Copper metal is oxidizing. They haven't mentioned that one, but you have to understand that one because definitely copper should be there in the right hand side. So therefore, copper should be oxidized into copper 2 plus. Copper 2 plus will be neutralized by the anion produced by this acid, copper nitrate. First of all, you have to write down the reaction in this way. Copper nitrate, nitric oxide, nitrogen dioxide. So they have given that nitric oxide and nitrogen dioxide are produced. So, but this is not the what we learned. Diluted HNO3 is going to convert into NO. Hot considered HNO3 is going to convert into NO2. So both of them are there. Yeah, under some specific conditions, both of the products can obtain. So we don't worry about that one. They have just given then got the you write down the products and try to balance the reaction. Right now, let's try to balance this one. Copper is oxidizing. Copper is oxidizing from 0 to, we can say that 0 to plus 2. Then the oxidation is 2 electrons. Students, here we have to be very, very, very careful. Why? The thing is, the reason is, you can see that there are two nitrogen atoms, NO and NO2. Here, nitrogen's oxidation number is plus 2, and here nitrogen's oxidation number is plus 4. And here nitrogen's oxidation number is plus 5. So this plus 5 oxidation state is reducing into plus 2 as well as plus 4 in another compound. Now we have to be very careful. So as you can see here in the right hand side, there are two nitrogen atoms changing its oxidation state. Therefore, let me put here 2 first of all in order to represent those two nitrogen atoms. Then what is the summation of those two oxidation numbers? What is the summation of oxidation numbers of those two nitrogen atoms? Plus 10. Plus 10. Because one nitrogen is converting into NO nitrogen. One nitrogen atom is going to convert into NO2 nitrogen. So what about this one? So here oxidation number is plus 5 money. So therefore, no need to concern. No need to consider. Because we are considering only the atoms who are changing the oxidation states at the beginning. Then you can see that the decrement is, can you see that? Decrement is 10 and here 6. 10 to 6, decrement is 4 electrons. Now we have to equalize increment and decrement. How do you do that one? You have to multiply this one by 2. You have to multiply this one by 2. This one by 1. 1 here, 1. Right? So, can you see that the number of nitrogen atoms are still not balancing? 1, 2. Here, how many nitrogens are there? Another 4 nitrogen atoms are there. In the right hand side, there are 4 nitrogen atoms. Then why the reaction is not balancing? Why this reaction is not balancing yet? Why this reaction is not balancing yet? What is the reason? Total number of nitrogen atoms are in the right hand side. 2 into 2 is 4. Here another one. Here another one. There are 6 nitrogen atoms. Okay, right. So tell me, students, why the reaction is not balancing? What is the reason? Why nitrogen atoms are not balancing? We have only 2 nitrogen atoms in the left hand side. Can anyone tell me? I told you the reason before. Here we have 6 nitrogen atoms, but in the left hand side, there are only 2 nitrogen atoms. Why? What happened to the remaining 4 nitrogen atoms? Who are they, the remaining 4 nitrogen atoms? Remember, these are nitric molecules which are acting as the oxidizing agent. Can you understand? So we know that nitric can play a dual role. Nitric is acting as the oxidizing agent as well as the acid. Here we haven't considered the nitric acid molecules. So therefore, you have to put another, how much we need? Here we have 6, we have only 2 here. We have to put another 4 nitric molecules, 4HNO3. Can you understand? So these are the acid HNO3, right? And these 2 nitric molecules are the oxidizing HNO3, oxidizing agent HNO3, right? Then no need to put this HNO3 separately. Then let me change this coefficient. 2 plus 4, answer is 6. Then we don't have to put that. Remember, this 6 is representing 2 HNO3 molecules which are acting as oxidizing agent and 4 nitric molecules which are acting as an acid. Now do the balancing part. How many hydrogens are there? 6. Then let me put here 3. Count the total number of oxygen atoms. 6 into 3 is 18. And here oxygen atoms are 3 into 2 6, 6 into 2 12, plus 1, plus 2, plus 3. Now then what is the summation? 5, 6, 18. Reaction is balanced. Right? So the 17th one, 18th one, and the 19th one, sorry, 18, 19, 20. So those reactions, you have to think. You have to use your brain. Now you have 17 experiences, right? We balanced 17 reactions before this one. So now you have some kind of an experience. Then you should be able to balance any kind of a redox reaction they have given using that oxidation number method. This is question number 18. Please raise your hand who understood this one. Please raise your hand who understood this. Do you have any doubts here? If you have any doubts, please put your doubts in the chat box. We didn't take the acidic medium. Okay. Now you know what to do. Right, okay. Are we done? Shall we move to the 19th part? Yeah. Let's move to the 19th one. Quickly, yeah. Nineteenth one. Consider the trivalent metal M reacting with nitric acid to form ammonium nitrate as a product. Write the balanced chemical reaction. Students, they have given that to consider a trivalent metal. Trivalent metal means the valency is 3. Valency 3 means probably that metal is forming M3 plus cation. So if it is trivalent, it can be M3 minus also, anion also. No, metals are forming cations. You know that sodium is forming sodium plus, aluminium 3 plus, magnesium 2 plus, those are metals. Copper plus, scandium 3 plus, titanium 4 plus. Likewise, these metals are forming cations. So therefore, we can consider that the metal capital M is oxidizing into Mn3 plus. Indirectly, they have given in this way. Valence is 3, trivalent. And it is reacting with nitric acid. Yeah, nitric acid, producing ammonium nitrate. Okay. HNO3. Just imagine this is like aluminium. Okay, then aluminium 3 plus is produced. Therefore, M3 plus is produced. That M3 plus should be neutralized by the nitrate. Then MnO3 thrice. Ammonium nitrate is produced. And definite byproduct is water. Right? Students, this is also same as the previous one. This is also same as the previous one. Here oxidation number 0. M is plus 3. 0 to plus 3, you can see that increment is 3. Ne? Then we can see that nitrogen's oxidation number here it is plus 5. And this is also nitrate, therefore don't consider because we are considering the one who changes the oxidation state. Here also we can see that ammonium nitrate is formed by ammonium plus and nitrate. Cation is ammonium, anion is nitrate. But nitrate is again not changing the oxidation state, same nitrogen. But in ammonium, we know that oxidation state of nitrogen is x plus 1 into 4, summation is plus 1. Then x plus 4 equal plus 1, x equal minus 4 plus 1, that means minus 3. Oxidation number is minus 3. For this nitrogen atom, only one nitrogen atom here, only one nitrogen atom. Plus 5 to minus 3. Plus 5 to minus 3, what is the decrement? Plus 5 to 0, 5. 0 to minus 3, 3. That means altogether 8 electrons are gained. 8 electrons. Plus 5 to minus 3. Then you have to equalize that. What we have to do? You are going to multiply this one by 3 and this one by 8. Let me put here 8, 8, 3 here, 3 here. That's all. So, but we have a big issue. I know it. Nitrogen atoms are not balancing, right? Yes. Same thing. Nitrogen, here we can 3 into 8, 24. And here we can see that 3, 2 nitrogen atoms are there. Then 6. Altogether, there are 30 nitrogen atoms. Oh my God. There are 30 nitrogen atoms. But here we have only 3 nitric molecules. Yeah, we know that these are the nitric molecules, or else these are the nitrogen atoms who are reducing. We didn't consider this nitrogen atom. We didn't consider this nitrogen atom. This one. So those nitrogen atoms came from where? those nitrogens came from the acid HNO3. This HNO3 molecule I have written is only representing the oxidizing agent HNO3. There is the acid HNO3. I have to mention it. Then how many acid HNO3 should come? 27 acid HNO3 should come. But remember, whatever it is, acid HNO3 or oxidizing HNO3, whatever it is, HNO3 is HNO3. Then we can add them together. 27 plus 3, how many? 30. Then I'm going to change the coefficient as 30. But remember, this 30 representing 3 oxidizing agent HNO3, 27 HNO3 which are acting as the acid. Now, okay, how many hydrogens are there? Hydrogens are 30. Here we can see that already 3 into 4, 12 hydrogens are there. And here we can see that H2O molecules, how much we need? We have to put 9. Then 9 into 2, 18, 30. Check whether finally the reaction is balancing or not by counting oxygen atoms. 30 into 3, 90 oxygen atoms are there. Here we can see that 8. And here 3 into 3 is 9. 9 into 8 is 72. Here we can see that 3 into 3, 9. And here also we can see 9. 72 plus 18, answer is 90. Confirm that the reaction is balanced. Reaction is balanced. Look at the way this, very interesting. So this is the 19th reaction I gave you. Right, okay, are we done? Shall we move to the 20th one? Yeah. In the 20th one, the last question, consider the metal, trivalent metal, capital M reacting with nitric acid to form nitrous oxide as a product. Write the balanced chemical reaction, easy, M, HNO3. So the previous reaction, only the change is one of the products. Way here, nitrous oxide into O plus water. Okay. Let me take the oxidation number of M, 0 to plus 3. Therefore, increment is 3 electrons. Okay. How many nitrogens are there here? 2 nitrogens. Therefore, let me put here 2. Then oxidation numbers will be plus 10. 2 nitrogen atoms are there. Here we can see that plus 2. Plus 10 to plus 2, decrement is 8. Then exchange and multiply. We have to equalize the increment and decrement, multiplied by 3, multiplied by 8. 8 here. Six. Okay. But the same issue, we can see that nitrogen atoms are not balanced. 24 plus 3, 27. Right? So here this one should be 16. 30. Here we have only 6. As we discussed, another 24 HNO3 molecules are adding there as acid. So therefore, we can change this coefficient as 30. Hydrogens are 30, therefore, this one should be 15. Finally, you can count the oxygen atoms. 30 into 3 is 90. And here we can see that 9, 72 plus 3 plus 50. 90. Reaction is balanced. So this is the 20th one. These are the 20 questions that we have to discuss to learn the redox. Okay, quickly complete this one. Right, are we done? Okay, students, please raise your hand who understood the 20 questions that we discussed. 11 questions are we discussing last Thursday theory class, and the remaining 9 here today. So please let me know. Do you have any doubts there? If you have any doubts, put your doubts in the chat box quickly. Right, okay. It seems that you don't have any doubts. Okay, now quickly go for the page number 43 in the TUT, question number 10. So I'm going to finish this exercise with you, but better you do this exercise again alone at home. But I'm going to discuss these questions quickly. Question number 10, page number 43. Quickly, huh? Balance the following reactions using oxidation number and half reaction method. So we didn't discuss the half reaction method, but we know what is the oxidation number method. So let's quickly complete this 20 reaction with the oxidation number method. Okay, right. Now everyone start with me. You all can do this one. So since they have given the products, you don't have to worry. H2SO4, potassium iodide, and HCl converting into H3SO3, arsenous acid, KCl, iodine, plus. Right. Okay. Let me do the balancing part quickly. So, who are the changing oxidation numbers? Iodine. So, therefore, we can put here 2. -2 to 0. -2 to 0, you can see that increment is 2. And here we can see that arsenic is +5. And here arsenic is +3. So, +5 to +3, what is the decrement? 2 electrons. Total increment and total decrement both are already equalized. Eh? So therefore we can see that we can multiply this one by one, that means one here, this one by one. How many potassium atoms are there? Two. Eh? Therefore let me put here two. How many chlorines are there? Two. Eh? So therefore we can put here two. How many hydrogens are there? 3, 5. Here we have 3. So therefore we can just keep this one as it is. You can see that oxygen atoms are 4 here, and here also 3 plus 1, 4. Balance. Okay, are we done? Easy, ne? Hereafter these things are very easy. They have given the products. Second one, number 2. Tin element is reacting with HNO3 to produce SNO2, NO2, and H2O. Right. So look at this one. So what is the oxidation state of tin here? 0, because it's a free element. And here we can see that oxidation number is plus 4. So 0 to plus 4, you can see that the increment is 4 electrons. And here nitrogen, in nitric, nitrogen's oxidation number is plus 5. Here nitrogen's oxidation number is plus 4. Plus 5 to plus 4, decrement is 1 electron. Then you have to equalize them, increment and decrement. Therefore, I'm going to multiply this one by 4, this one by 1. Put 1 here, 4 here, 4 here. Got it? As you can see here, how many hydrogens are there? 4. Therefore, let me put here 2. When you count the total oxygen atoms, 4 into 3 is 12. Here we can see that 2 plus 8 plus 2. Reaction is plus. Very easy. Very, very easy. Quickly complete the exercise. Hands up who balanced the third one. Anyone here who balanced third one? Not yet. Done. Let's move to the third one. Yes. Zainab, let's see whether your answer is correct or wrong, right? Let's see. Potassium nitrite KNO2 reacting with potassium permanganate KMnO4 in the presence of sulfuric. giving potassium nitrate KNO3, manganese sulfate MnSO4, potassium sulfate plus water. Right. I think this is very easy. So manganese plus 7 plus 2. So therefore the decrement is 5. Nitrogen plus 3 plus 5. Increment is 2. Then in order to equalize them, you multiply this one by 2, this one by 5. Let me put here 5. 5 here, 2, 2 here. Okay. Can you see that all the potassium atoms in the left hand side, 7. Here we have 5. Here we have 2, or therefore 1 here. All the sulfur atoms in the right hand side, 1 here, 2 here, 3. Then let me put here 3 sulfur. Okay. Then you can see that how many hydrogen atoms are there? 6. Put here 3. In order to check whether the reaction is balanced or not, count the oxygens. 10 here, 8 here, 12 here, 30. 15 here, 8, 4, 3, 15, 30. Yeah, the reaction is balanced. So this is the third one. Here is the third one. Zainab, your answer is correct. Vidushana, your answer is correct for the third one. Quickly go for the fourth one. Right. Let me do the fourth one also, and let's check your answer is correct or wrong. Duara, I have uploaded the questions, 20 questions to your WhatsApp. Check your WhatsApp. Check your WhatsApp. I uploaded that one. So these are the 10 questions that I'm discussing. Fourth one, potassium dichromate, potassium iodide, sulfurate. So they have given the products iodine, chromic sulfate, potassium sulfate plus water. Now in this reaction, there are 2 iodine atoms, therefore let me put here 2, minus 2 to 0. Increment is 2. And here you can see that chromium atoms, 2 chromium atoms are there, plus 12. Here also 2 chromium atoms are there, plus 6. Plus 12 to plus 6, decrement is 6. Therefore multiply this one by 3, this one by 1. Already 2 is there, so therefore 2 into 3 is 6. 1 here, 1 here. Can you see that number of potassium atoms are 8? 4 here. How many sulfur atoms are there? 4, 3, 7. then we can put here 7 sulfuric. All the hydrogens are 14, therefore we can put 7 again. Finally, you can check whether the reaction is balanced or not by counting oxygens. 35 oxygen atoms are there. In right hand side, 12 plus 16 plus 7. Yeah, 35 oxygen atoms are there. So therefore reaction is balanced. Raise your hand who got the correct answer for the fourth one. Okay. Vidushana, Zainab, Akshada. Good. Marisha, good. Very good. Right. Let's move to the next one. Let's check whether your answer is correct or wrong. The next one. Copper sulfide, HNO3 converted into copper nitrate, sulfur, nitric oxide, H2O. Copper's oxidation number 0 to +2. And one more thing, sulfur's oxidation number here -2. Sorry, this is +2 to copper's oxidation number is not changing, +2 +2. But sulfur's oxidation number -2 here, 0. Therefore, the oxidation is taking place on sulfur, 2 electrons. Nitrogen's oxidation number here, +5. Only in nitric oxide, nitrogen's oxidation number is changing, which is +2. +5 to +2, decrement is 3. Decrement is 3. Therefore, you can multiply this equation by 2, this one by 3. Right? As you can see here, number of copper atoms are now 3. We can put here 3. Students, did you notice that nitrogen atoms 3 here, 2 here, and here 2 into 3, 6. So therefore, 8 nitrogen atoms are there. 8 nitrogen atoms are there. So we know that nitric is acting as oxidizing agent as well as acid. So acid HNO3 is not added. Therefore, we have to put that one 6 HNO3, then 6 and 2, 8 HNO3. Then total number of hydrogens are 8. That means 4. So when you count the oxygen atoms, 3 into 8, 24. Here 6 into 3, 18. 2 plus 4, 24. 24 oxygen atoms are there. reaction is balanced in this way. Number 5. Vidushana, your answer is correct. Akshada, your answer is correct. Yes, very good. Number 5, your answers are correct. Number 6. Let's see how we can balance this one. There are 4 arsenic atoms. Therefore, let me put here 4. So free element, therefore 0 oxidation state. And here arsenic is +5. Then we know that +5 into 4 +20. So the total increment is 20. And nitrogen, you can see that nitrogen's oxidation number is +5 here and here +2. So therefore +5 to +2, you can see that the decrement is 3. Students, did you notice that here water molecules are added to the left hand side? I told you that normally water is added to the right hand side, but some of the reactions are there, water molecules added to the left hand side also. Right, now we have to equalize increment and decrement. Let me multiply this one by 20, this one by 3. Let me put here 3. So here 12. This one by 20, 20 here. Right? So you can see that all together there are 36 hydrogen atoms. Neither 12 into 3 is 36. Here we have only 12, 20. Then how many hydrogen we need? We need 36 means we need 16 more. That means 8. If the reaction is balancing perfectly, you can check whether the oxygen here we have 60 plus 8, 68. Here how many oxygens are there? 12 into 4, 48 plus 20, 68. So it's confirmed that the reaction is balanced. So the sixth one is like this. Yes, Vidushana and Akshada, your answers are correct. Very good. Yeah, Akshada, next answer is also correct. Very good. Yes, very nice. 7, 8, both are correct. Vidushana, correct. Seventh one is correct. Good, very good. So when we'll have our next online exam, soon after second unit completed, you will have unit test for the second unit. Soon after third unit is over, unit 3 test will be there. Both of them are MCQ papers. So get ready for that one. My plan is to finish second unit and third unit by December. I'm going to put some extra classes Friday, Saturday morning. I think this time is okay for you because in if I put weekdays, what will happen is some of you are going for physical classes. So therefore, physical classes teachers are putting some extra classes. No? So therefore, better we take Saturday morning, I guess. Okay, I'll inform that one. We have to cover some theory parts. And paper class will be started from January. Right. Now let's move for the seventh one. Seventh one is easy. Iodine is reacting with HNO3. It is converted into HiO3 NO2 plus H2. As you can see here, there are two additives. So therefore 0 and here plus 10. 0 to plus 10, you can see that 10 electrons are there. Increment is 10. Nitrogen here plus 5. Plus 5 to plus 4, decrement is 1 electron. You can multiply this one by 10 to equalize the increment and decrement. How many hydrogens are there? 10, but here we have 2. We need 8 more, therefore 4. In order to confirm whether the reaction is balanced or not, you can count the oxygens. 30, and here we can see that 2 into 3 is 6, 20 plus 4, 30 oxygen atoms are there. So this is the seventh one. Let's move to the eighth one also. Eighth one also easy. I2O5 is reacting with hydrogen sulfide to produce sulfur, iodine, and H2. Here iodine's oxidation number is plus 10 and here 0. Plus 10 to 0 reduction by gaining 2 electrons. And here sulfur minus 2. Minus 2 to 0 increment by 2 electrons. This is multiplied by 5. This is multiplied by 1. And you can see that number of hydrogens are 10. Eh? Therefore, you can prepare 5. And you can see that oxygens are 5 here. Here also 5. Easy. Eh? So the 7th one, 8th one, both are easy. It's not that much of a big deal. Okay. 7, 8. I think 9th one, we already did that one. We discussed that one. Ferrous oxalate, potassium permanganate. Okay. So let me quickly do that one since we have discussed 9th one earlier. H2SO4, ferrous oxalate, Fe2C2O4, potassium permanganate. Manganese sulfate, Fe3SO4, Fe2SO4 thrice, carbon dioxide, potassium sulfate plus water. Manganese plus 7 to plus 2. Decrement is 5. Here there are 2 ion atoms, plus 4 to plus 3, plus 4 to plus 6 increment. There are 4 carbon atoms in the left hand side, therefore let me put here 4. So therefore here we can see that plus 16, here plus 12. Then total increment is plus 16 to plus 26, 6 electrons. Then you have to multiply this one by 5, this one by 6. Then this becomes 10, 5, 20. Number of potassium atoms, 6 here. Therefore 3 here. Number of sulfur atoms, 3, 15, 18, 24. 24 sulfuric. And here we can see that how many hydrogens? 48 hydrogens. Now count the oxygen atoms. 96, 40 plus 24. So the summation is 160. In the right hand side also 24 plus, 60 plus, 40 plus, 12 plus 24. Summation will be 160. This is the ninth one. Let's move to the question number 10. AS4O6 HNO3 reacting with water to produce H3ASO4, arsenic acid, nitric oxide, and nitrogen dioxide. Okay, let's see. As you can see here, there are 4 arsenic atoms. Let me put here 4. Oxidation numbers of these 4 arsenic atoms will be plus 12. Here arsenic is plus 5. Plus 5 into 4 is 20. So therefore plus 20. Plus 12 to plus 20. Total increment is 8 electrons. And here nitrogen's oxidation number is plus 2 and this is plus 4. That means 2 nitrogen atoms are there. Therefore, let me put here 2. When you take the 2 nitrogen atoms here, plus 5 into 2 is plus 10. Then when you consider the total decrement, plus 10 to plus 6, decrement is 4. Right? Then you have to multiply this one by 2. That means you are multiplying this one by 2 and this one by 1. That means 4 here, 2. Okay. Ne? Number of nitrogen atoms are balancing, arsenic atoms are balancing. What about hydrogen atoms? In the right hand side, there are 12 hydrogens. 12 hydrogens are there in the right hand side. Here we have 4 only. Then we know we need 8 more. Then let's put here 4. Then 4 into 2 is 8. 8 plus 4 is 12. How many oxygens are there? 6 plus 12 plus 4. 22. In the right hand side, 16 plus 2 plus 4. 22. It's confirmed that the reaction is balanced. So this is question number 10. Anyone completed question number 11? Anyone here? No one, not yet. So quickly do it. Huh? Okay. Let's go for the 11th one quickly. P4 sodium hydroxide plus water giving phosphine pH 3 NaH2 PO2. Right? Now we have to balance this one. Here phosphorus is 0. Here we can see that minus 3 into 4 is minus 12. So the decrement is 12. So this is a disproportionation reaction. Therefore, let me write down here another P4 molecule. Here phosphorus oxidation number, what should be? Sodium plus 1, hydrogen plus 1 into 2. This is x minus 2 into 2, summation equals 0. Then we have plus 3 minus 4 plus x 0. X equal plus 1. Oxidation number is plus 1. But we have to equalize the phosphorus atom. So plus 1 into 4 is plus 4. And here's 0. So 0 to plus 4, increment is 4. Then you have to equalize increment and decrement. In order to equalize increment and decrement, let me multiply this one by 3, this one by 1. How many sodiums are there? 12. This right? How many hydrogens are there? 24. 24 plus 12, 36. Here we have 12. Then we need 24. We can put 12 here. Is the reaction is balancing perfectly? How do you check that one? Yeah, 12, 12. We can see that 24 oxygen atoms are there. And here also 24 oxygen atoms are there. Yeah, reaction is balancing perfect. But did you notice that we can simplify this one? We can simplify this reaction. Right? We can simplify this reaction in this way. Four P4, 12 sodium hydroxide, 12 H24, 4 phosphine, 12 NaH2PO4. So you can see that all the coefficients are divisible by 4. 1, 3, 3, 1, right? P4, 3 sodium hydroxide, 3 water molecules, phosphine, 3 sodium H2PO4. Balanced chemical reaction. So this is the 11th one. Yeah, Vidishana, let's check whether your answer is correct or wrong. Quickly complete the 11th one. Right, let's move to the 12th one. Zinc reacting with potassium hydroxide, potassium nitrate, then giving potassium zincate, ammonia plus water. Then how we can balance this one? Zinc 0 here. Here we can see that zinc is plus 2. 0 to plus 2, increment is 2. Nitrogen here plus 5, minus 3. Plus 5 to minus 3, decrement is 8 electrons. Then you have to balance this one by equalizing the increment and decrement. Therefore, let me multiply this one by 4 and this one by 1. There are 8 potassium atoms, 8 potassium atoms in the right hand side. Here we have 1, then 7 potassium hydroxide. How many hydrogens are there? 7. We have 3. Then we have to. How do you check whether the reaction is balanced or not? By counting oxygen. 7 plus 3, 10. And here we have 8 plus 2, 10. Yeah, confirm that the reaction is balanced. So this is the 12th one. Look at the 13th one. There are two arsenic atoms. Oxidation number will be +6 here. And here +10. +6 to +10, you can see that increment is 4 electrons. Manganese, here you can see that oxidation number is +7. And here +2. +7 to +2, decrement is 5. Then we can equalize increment and decrement. That means you are going to multiply this one by 4 and this one by 5. Put 5 here, 5 here, 4 here, 4 here. Then how many sodium atoms are there? 4 sodium atoms, right? How many chlorines are there? 4, 8, 12. How many hydrogens are there in the left hand side? 12. Therefore 6. Finally, to check whether the reaction is balanced or not, you can count oxygen. 15. 5 into 3 is 15. 4 into 4 is 16. That means this is 31. Here, 25 plus 6, 31. So it's confirmed that the reaction is balanced. So this is reaction 13. Quickly balance these things. Let's see, Vidushana. Let's see the next one. 14th one. Bi2O3. Sodium hypochlorite. Sodium hydroxide. NaBiO3, NaCl plus 4. So here you can see that bismuth, 2 bismuth atoms are there. Oxidation number here it is +6 for the both atoms. In here BiO3 minus x minus 2 into 3 summation -1 x equal +5. So therefore +10. +6 to +10, increment of the oxidation number is here chlorine's oxidation number is +1 and here chlorine's oxidation number is -1. +1 to -1, you can see that decrement is 2. Then in order to equalize total increment with the decrement, we are going to multiply this one by 2. Then you can see that the total sodium atoms are 4. We can put here 2. How many hydrogens are there? 2. 2. In order to check whether the reaction is balancing, you can count the oxygens. 3 here, 2 here, 2, 7. And here also you can see that oxygen atoms are 6 plus 1, 7. So it's confirmed that the reaction is balanced, right? 14th one. Let's go for the 15th one, number 15. Yeah, let's see. HCl is reacting with potassium nitrite KNO2, cobalt chloride COCl2, converting, and it's producing K3 NO2 6 times. Here we have to put a square bracket. Huh? This is a complex compound. We have discussed these things. KCl, NO, and H2. Okay, students, who is changing the oxidation state here? Nitrogen. Here, nitrogen's oxidation number is +3, neither. And here, nitrogen is +2. So, +3 to +2, you can see that the decrement is just 1 electron. So, this is a complex cation. So, I will separate the cation anion, K plus CONO2 6 times 3 minus. We know that the ligand is NO2 minus, ligand. So NO2 minus means -1 into 6. Let me take oxidation state of cobalt is X, summation is -3, X minus 6 minus 3, so therefore X equal +3. Oxidation state of cobalt here, it is +3. It is +3. Then you can take that cobalt is changing its oxidation state from +2 to +3, increasing, just 1 electron. So therefore nothing to worry, just by 1 electron. So already increment, decrement both are equal, 1 and 1. So therefore these coefficients never changes. Here also 1. Here also 1. Here also 1. But you can see that students, there are 2 chlorines, so therefore we have to put 2 chlorine. But how many potassium atoms are there in the right hand side? 2 is there, and here is 3. Altogether 5. No, we can't take like. Did we do any mistake here? Nitrogens are 7. Yeah. So here, wait. Here we have to take that nitrogens are 7. Here we have 6 and here 1. So therefore we have to put here 7 nitrogen because NO nitrogen is here. We have to put 7 here. Then how many potassiums are there? 7. Here we have 3. Then we have to put 4 cases. Then total chlorine atoms are 4. Then 2 here. 2 here, chlorine atoms are balanced. Hydrogens, 2. Therefore 1. In order to check whether the reaction is balanced or not, you can count oxygen. 14. Let me see here. 12. 2 into 6 is 12. Plus 1, yeah, 14. Reaction is balanced. Okay. Right. So this is something very important. No? Please raise your hand who got the correct answer for question number 15. Who balanced the question number 15 correctly? Anyone here? Vidushana, very good. Yes, very good. Some of the coefficients has to be changed according to the requirement of the reaction. Okay, sometimes we have to do that. Let's go for the 16th one. Potassium iodide, HCl, calcium hypochlorite, producing calcium chloride, iodine, KCl plus water. Then you can see that iodine is changing its oxidation state. Ne? You can see that here to -2 to 0. So it is increasing. Oxidation is taking place on iodine by 2 electrons. And then chlorine. Chlorine is changing its oxidation state. We have to put that one. Okay, let me take here. There are 2 chlorine atoms here. So 1 chlorine's oxidation number is +1. +1 into 2 is +2. And here chlorine is -2. So +1 to -2, what is the decrement? 4 electrons, right? +1 to 0, 2 electrons. 0 to -2, 2 electrons. So therefore 4 electrons. In order to equalize the increment and decrement, what we have to do? We can multiply this one by 2 and this one by 1. Therefore 4 potassium iodide. Now number of potassium atoms are constant, right? 4. Let me put here 4. Then chlorine atoms in the right hand side, we can see that 6. And here we have 2. So therefore 4 HCl. How many hydrogens are there? 4. 2 here. Then you can see that in the left hand side also we have 2 oxygen. In the right hand side also we have 2 oxygen. So the reaction is balanced. So this is question number 16. Very easy. It's not that much difficult. Anyone here who balanced the 17th one? Anyone here balanced 17th one? Vidushana, okay, very good. What about the others? Akshada, Bishon, Marisha, Zainab, Yenuli, Asasi, Sharfa, Sharaf, Duara, Shara, Shainas, Bishon, Ayesha. Anyone? Marisha got the answer, very good. Right. Then let's go for the question number 17. I think hereafter redox will be nothing for you all, right? Vidushana, what do you say? Is redox difficult? Maybe redox kotala pola dinya. It becomes easy after so many practice. Yes, that is the point. Yes, because some of the students are thinking that just by doing one or two reactions, redox is okay. It's not like that, neither. Each and every reaction is a nice, good experience. That's why I told you. We have to learn something new. Why these students are not understanding that? Right, 17th one. Sodium hydroxide, cobalt chloride, COCl2, reacting with H2O plus sodium peroxide, Na2O2, producing cobalt hydroxide, COOH thrice, and NaCl. Students, you can see that in here, Cobalt is increasing. Oxidation number +2 to +3. Its oxidation number is increasing, and here one electron is contributing. So now here you have to understand that who is reducing? Oxygen, because this is sodium peroxide. I told you that we have to be very careful when oxygen is connected to group number 1, group number 2 like elements. So here oxygen's oxidation number, when you consider one oxygen atom, that is -1. But in the right hand side, we have oxygen only in this reaction. Okay, but here there are 3 oxygens. So first of all, we have to equalize them. Therefore, let me multiply this one by 3 and this one by 2. Then there are 6 oxygens. So for one oxygen, oxidation number is -1. For 6, -6. Here we can see that hydroxide in hydroxide means oxygen -2. So there are 6 oxygen, -2 into 6, -2. -6 to -12, you can see that the decrement. What is the decrement? Decrement is 6 elements. In order to equalize them, let me multiply this one by 6 and this one by 1. So that means you have to multiply this one by 6. Right? And we have to convert this one into 6 again. That means this becomes 12. That means cobalt atoms are 12. Right? Then we have only 6 cobalt atoms. Then what we supposed to do? So here we have to be very careful. Okay, what to do? Again, I'm changing the cobalt atoms as 12. I don't have any option. And you can see that there are 24 chlorine atoms. Let me put here 24 sodium chloride. How many sodiums are there? 24. Here we have 6. And then we need 18 more. Then let me put here 18. Okay, 18. And you can see that how many hydrogens are there in the right hand side. So here water molecules are added to the left hand side. Hydrogen side, right hand side is containing 36 hydrogens. So here we have 18. Then we need 18 more. 9. How many oxygens are there? 18 plus 9 plus 6. We have 15. It means 33. Now the reaction is not balancing. Reaction is not balancing. 17th one. What is the mistake that we did? +2 to +3. Increment 1. Sodium 6. It's -2, 6. (24) chlorine atoms means here we have to put 20. 24 sodium means 8. . Then hydrogens are 36 now. 3, 36, 18, 18, 36. Oxygens are 18, 9, 27, 30. But here we have 36. Did I write the reaction correctly? Sodium hydroxide, cobalt fluoride, H2O, sodium peroxide, cobalt hydroxide. Students, anyone who balanced the 17th one? Anyone here? Vidushana, you got two cobalt chloride, sodium chloride. Vidushana and Dwara, you got the answers, no? Right. Let me do that one again. Sodium hydroxide, cobalt chloride plus water plus sodium peroxide Na2O2, giving us cobalt hydroxide plus NaCl. Oxygen atoms are 2, so therefore let me put here 3. Then minus 6, minus 12. So minus 6 to minus 12, decrement is 6. And here you can see that cobalt. There are 2 cobalt atoms. Therefore, we have to consider 2. Right. Okay. So that is the mistake that we have. So here we have 2 cobalt. Then we have to put 2 here. Then plus 4. And here plus 6. So plus 4 to plus 6, increment is 2. Now, okay. Now you can multiply this one by 1. And this one by 3. So when you multiply this one by 3, this becomes 6. 6. Okay. Right. Now, okay. Now you can see that there are 12 chlorine atoms, so therefore 12 sodium. Here we have 6. Here we also can put 6. How many hydrogens are there? 18. 18 means we can put here 6. What about the oxygen? 6, 6, 12, 12, 12, 6, 18, 18. Reaction is balanced. But you can see that all the coefficients are divisible by 3, no? Then 2 sodium hydroxide, 2 cobalt chloride, 3 water molecules, 2 water molecules, 1 sodium peroxide, and this becomes 2 cobalt hydroxide, cobaltic hydroxide, and we divide this one by 3, 4 sodium chloride. Now, okay, neighbor? 6 here. There are also 2, 4, 6. Reaction is balanced. So we have to be very careful, huh? Since we didn't equalize the cobalt atom, when I'm doing that one, actually I got the wrong answer. Right, okay, let's quickly move to the 18th one also. Let's finish this one. 18th one, manganese oxide, lead oxide PbO2, HNO3, giving us lead nitrate PbNO3 twice, HMNO4. So we can see that manganese oxidation number here +2, and here manganese oxidation number is +7. So +2 to +7, you can see that decrement is 5. And here you can see that lead oxidation number is +4, +2, +4 to +2. You can see that decrement is 2 electrons. Then you can equalize decrement and increment. So 2 here, put 2 here, put 5 here. And you can see that nitrogen atoms here, 10. How many hydrogens are there in the left hand side? 10. So they are for 5. In order to check whether the reaction is balanced or not, you can count oxygen 2 plus 10 plus 30. We have 42 oxygen atoms. And here we have 630, 8 plus 5. Reaction is not balancing. Why? What is the mistake? Hydrogens here we have 10. 10 means we have to put here 4 because already there are 2 hydrogens here. So then, now okay, 12, 42. Reaction is balanced. 18th one. Anyone here completed last 2 reactions, 19th one and the 20th one? Akshada got the answer. Vidushana got the answer. Very good. What about the 20th one? Last 2 reactions. Let's move to the 19th one. So in the 19th one, we can say that FeCl2 reacting with HCl plus hydrogen peroxide H2O, giving us that FeCl3 plus H2. Iron atom is changing oxidation number from +2 to +3. So therefore increment is just 1 electron. Here there are 2 oxygen atoms. So therefore oxidation number -2 to -4. So -2 to -4, you can see that the decrement is 2 electrons. Because there are 2 oxygen atoms, we have to consider both. So let me multiply this one by 2 and this one by 1. 1 here. Put 2 here, 2 here. You can see that there are 6 chlorine atoms. Right? We have already 2, we are already 4. Then put here 2. Hydrogens are 4, oxygens are 2. So the reaction is balanced. Hereafter, reaction is balanced automatically. 19th one. Anyone completed 20th one? Anyone completed 20th one? Vidushana, good. Akshada, Zainab. What about you? Marisha? Okay, Marisha, good. 20th one. AS2S5 reacting with HNO3 to produce arsenic acid H3ASO4, sulfuric acid H2SO4, nitrogen dioxide plus water. So there are two arsenic atoms. So therefore, let me put here 2. So here we can say that oxidation number will be sulfur is -2. Right? So therefore, plus 10. Here arsenic is not the one who changing oxidation state. He also +5, he also +5. Then sulfur is the one who changing oxidation state, right? So here 5 sulfur atoms. One sulfur atom's oxidation number is -2. So -10. Here we know that sulfuric, sulfur's oxidation number is +6. So therefore +30. Then -10 to +30, -10 to +30. What is the increment? 40. 40. Then in nitric, we can see that nitrogen's oxidation number is +5, and here +4. +5 to +4, you can see that decrement is 1 electron. Then you know what to do. Multiply this one by 40 and this one by 2. How many hydrogens are there? 40 hydrogens are there. Here we have 3 and here we have 10. We need 13. First of all, we have to balance arsenic. 2 arsenic atoms are there. So therefore, we have 6 hydrogens, 10, 16. In order to become 30, we need 24. That means 12. Now check whether the reaction is balanced by counting oxygens. 14 to 3, 120. And here 8 plus 20 plus 80 plus 12. 100, 120. Yeah. So the reaction is balanced. Right. Okay. So this is all about the redox reactions. I discussed all the 20 questions in the exercise, page number 43 in the tutorial, question number 10. So altogether, how many redox reactions that we discuss using this short method? 40 reactions, right? 40 means 39 because one reaction repeated. Doesn't matter. So anyhow, you should be able to balance the redox reactions hereafter. This is the balanced reduction in the short method. Now I won't discuss the short method hereafter. So if you meet the questions, you will again meet the questions in the paper discussions, right? So in the next session of chemical calculations, let's go for directly half reaction method. Then we can go for half reaction method and see. Let's see how to balance the reactions in ionic method using half reactions and okay, right. Okay, do you have any doubts, students? Do you understood what you learned today? Anything, any doubts? Please raise your hand who understood the things that we discussed today. Okay, good. Okay, then students, let's meet on the next Thursday theory class. Before that, I will upload the rim paper and continuous paper. To yesterday, actually, I couldn't upload that one. I will upload the rim paper discussion and the continuous paper discussion. Okay, and I will upload this recording also. Then let's meet on Thursday. Bye bye. Have fun.